Yo, college algebra students. We're going to look at graphs of rational functions again. And you really probably remember what these look like. They're not that bad. You have like y equals 1 over x. We call that the reciprocal function. And I think you should remember that it looks kind of like this. And if you switch that, y is equal to 1 over x squared, then you have just a slightly different graph. If you square something, it's going to make it positive. And so you can see what you get. Okay, those are kind of some options there. So in this situation, it's going to be a horizontal shift to the left, 2, and there's no vertical shift. And so this is your graph. Piece of cake upside down, right? As you look at this, we're just going to identify the asymptotes. Don't worry about domain and range, but the vertical asymptote is going to be x is equal to -2. And the horizontal asymptote is going to be y is equal to 0. Okay, we'll look at the next one. It's going to be shift to the right 3. Don't worry about the 2 on top. You can really ignore it. It just creates a stretch. We're not going to have to show that stretch. We'll show the shifts. And the negative also flips it upside down. Because it's squared, they're both in adjacent quadrants. So the vertical asymptote is going to be x is equal to 3. And the horizontal asymptote, again, is going to be y is equal to 0. The next one, there is no horizontal shift. But there is a vertical shift. And so we have a graph here, graph there. So our horizontal asymptote is y is equal to 3. Our vertical asymptote is x is equal to 0. Hopefully you remember these guys. This is just a little bit of review as we then head on. Here it's going to be a shift to the right 3 units. And there's no vertical shift. 5th power, so it's going to look like this guy because it's an odd power in the denominator, so they'll be in adjacent opposite quadrants instead of adjacent quadrants. If it's an even power, then they'll be right next to each other. The negative is going to flip this. So I've got that, and I've got that. Horizontal asymptote of y is equal to 0. Vertical asymptote of x is equal to 3. Three to the right and up 2. Those are our transformations. Horizontal shift. Horizontal asymptote. Y is equal to 2. Vertical asymptote, x equal to 3. We got this last guy. We're going to go to the right 2. We're going to go up 1. Since it's squared, they will be next to each other. Negative flips them upside down. So horizontal asymptote of y is equal to 1. Vertical asymptote of x is equal to 2. Okay, so what happens when they look different in form? You can see that we don't have a number on top, we have x on top. What we are going to do is we are going to divide x plus 3 divided into x plus 0. What do you multiply x by to get x? You multiply by 1. So we have x plus 3, and we subtract. We get 3. So we write this as 1 plus, -3, excuse me. So 1, sorry about that. Negative 3. So 1 minus 3 over x plus 3. Or if I write that a different way, negative 3 over x plus 3 plus 1. Now, here's what's really interesting about that graph. What's interesting about that graph is you know that it shifted back 3 units. And you know it shifted up 1 unit. The negative will create that vertical flip that you want. So when you put it into the appropriate form, you can see already what it looks like. Now, here's something else to consider. Oh, I just saw I made a mistake. I'm sorry. Now I saw. I drew them in the wrong quadrants. And here's how I knew. We're going to show you something else that's interesting. Something you should be able to do when it comes to rational functions is find the x and the y intercept. So we're not going to have you list the horizontal and vertical asymptotes in this example because we've been drawing them, you know what they are. But list the x and the y intercepts. The y-intercept happens when you plug in 0 for x. So 0 over 0 plus 3 is 0 over 3, which is 0. That means it crosses the y-axis at 0. To find the x-intercept, we set the function equal to 0. So 0 over 1 equals x over x plus 3. Watch what happens when you cross multiply. 0 times x plus 3 is 0, and x times 1 is x. You get 0 as x. So you can tell that this is going to cross down here. And this is going to cross up there, which matches with our flip that we were talking about. So in each of these, I'm going to identify the x and y intercept. In fact, we'll even start by doing that right away. Since we just did it, kind of clarify something for you. Find the y-intercept, you plug in 0 for x. And you can see you get 4 over negative 1, which is negative 4. And to find the x-intercept, you plug in 0 for y. When you cross multiply, 0 times that gives me 0 equals 4 minus x. If you notice, it always just ends up being the top equal to 0. I tried to teach it before like that, but people got confused. So x is 4. So we've got x is positive 4 and y is negative 4. We know that those are 2 points. To come up with the rest of the graph, take x minus 1 and divide it into negative x plus 4. What do we multiply x by to get x? Negative x, we multiply by negative 1. Negative x plus 2, we get 2. So it's plus 2 over x minus 1. Or in other words, 2 over x minus 1, or x minus 1 minus 1. So that means a horizontal shift to the right, 1 unit. And then a shift down 1 unit. And then we can go through those points. Next one's a little bit different. I'm going to allow you to investigate this one with me by plugging it in to your calculator. I'm going to turn it on here. We're going to go x squared minus 4x plus 6. And we're going to divide that by x plus 2. Now let's see the shape that you get. Wow, that's kind of interesting. I'm going to zoom out. I'm going to change my window to negative 100 to 100. I'll put a tick mark every 10. then negative 100 to 100. Let's look at that graph. It's interesting. It almost looks like a line, but something crazy happens. In fact, something crazy happens right around that value of negative 2. You can see if I put on my trace and I move to the right, you can see that tracer mark as I move now to the right. So I get negative 10, negative 8, negative 6, negative 4. Looks like if I get close to negative 2, it just bottoms out down there. All of a sudden joins on the other side. So something crazy happens at negative 2. Are you surprised that something crazy happens at negative 2? You shouldn't be. You can see that that's where the function has something that disrupts it. Let's try to take the x plus 2 and divide it in and see what happens. X squared minus 4x plus 6. When we divide it in, x times x is x squared. X squared plus 2x. I subtract, and I get negative 6x plus 6 multiplied by negative 6. Negative 6x minus 12, and we subtract, we get 18 plus 18 over x plus 2. I would like to try to make sense of this with you. Okay. We get 18 over x plus 2 plus x minus 6. Now, if you looked at your previous examples, see how you had this minus 1 on the end? That gave you this graph of negative 1. See how I have this plus 1 on the end? That gave you this graph of plus 1. Here you have an x minus 6 on the end. That's going to give you a graph of x minus 6. So instead of a horizontal asymptote, this has what we call a slant asymptote. And we know it's undefined at negative 2. So it looks like that. In fact, if you take your calculator, I'm just going to zoom standard again so we can kind of see a little bit of what's happening here. And if with that graph, if I plug in that x minus 6, I should get a line that comes really close to what we just said graph there. Look at how that graph, as it goes out, they kind of come together. In fact, if I take this window out a little bit further, we'll go negative 25 to 25. Or negative 25 to 25. There it is. That x minus 6, you can see how the graph wants to look like that. It just has that disruption at negative 2. And sure enough, graph kind of just falls along with those asymptotes. We call that a slant asymptote. At the next one, this one's interesting. So if I try to graph it ahead of time. So an approach I'm trying to show you guys this year that's different from last year's is, or you can actually maybe graph these ahead of time and then try to do the algebra to confirm why it looks the way that it looks. Zoom 6. Just looks like a horizontal line. Huh. I wonder why. Let's see what happens when we divide it. 2x minus 4. Actually, we're just going to take this. We're going to go x minus 2 over, and then I'm going to factor out a 2 out of the bottom, and I get an x minus 2. Look what happens. Those cancel off, and we get a value of 1/2. So the function actually looks like this line of 1/2, except something silly happens right at a value of 2. If I go to my calculator and I zoom as a decimal, zoom number 4, going to give me that same line, except look what happens. If I press trace, look what happens as I move along here. Look what actually happens at 2. You can actually see the pixels on your calculator. There's a spot missing. Sure enough, when I go to 2, there's no y value. So I move to the right, it's gone. So if something divides off completely, it means that there's a hole there. It's actually a gap. An interesting function, a rational function, sometimes can produce a hole like that. If something divides out evenly, then that's what's missing. The rest of the function looks like y equals 1/2. But for that one spot, it's missing. In fact, if we go to our table and you were to type in values like, 1.8, 1.9, 2, 2.1, 2.2, you can see as soon as you get to 2, you get an error. There's no value there. So how we show that with our graph is we have a hole right there. Okay. Try to put it all together for you in this example. Okay, we have x squared plus x over x squared minus x. I'll find the y-intercept here, just so we can kind of see it. The y-intercept, if you plug in 0 for x, you can see that you actually get 0 divided by 0. Huh. Wonder what that's all about. And then the x-intercept, if you set the top equal to 0, you would get x times x plus 1. So it looks like 0 and -1. Maybe we better have a look at this ahead of time and see exactly what's going on. X squared plus x, and I divide that by x squared minus x. Make sure you put parentheses around those. Okay, that's interesting. Why do we get that? Well, what do you notice you can do? You can factor an x out of the top and you get x plus 1. You can factor an x out of the bottom and you get an x minus 1. So notice how those cancel. Okay? So this is what the graph wants to look like. X minus 1 divides into x plus 1. X minus 1 divides into x plus 1. What do you multiply x by to get x? Multiply by 1. X minus 1. Subtract. We get 2. So plus 2 over x minus 1. So 2 over x minus 1 plus 1. So you can tell that your graph is going to be shifted 1 to the right. It's going to be shifted 1 up. We've got this interesting thing here where you see that the x divided off. That means that there's a hole at 0. You can tell from our x and y intercepts, we knew that something funny was going to happen at 0. So how do we tell where the hole is? Well, if you plug 0 into this guy, you can see you get 2 over -1 plus 1. Which will be -2 plus 1, which is -1. So there's a hole at 0. 0, -1. So this spot right here, that's where the hole is. I showed you guys earlier how you can kind of see the whole zoom as a decimal is a great way to do it. But if I zoom as a decimal here, notice you can't really see that there's a spot missing. If I go into second format and I take off my axes and I look at the graph, now you can see that spot is missing. If I go to my trace, notice when I get to 0, it's gone. Right on the other side, it's back there. So sure enough, there's a spot missing on the graph. So anytime something divides off, there's a spot missing. All right, a little bit complicated of a lesson. Difficult lesson is something that in other years I try to maybe break out into 2 days and kind of go section by section. You're not going to be tested on this, but it is good stuff to practice, and I hopefully have your worksheet as organized as I possibly can for you. We'll see you guys on Google Meets. Later.